is the loose tube, is the fiber, loose fiber in tube or loose tubes. And considering the kind of installation, we can use cables in ducts, we can use directly buried, or can use aerial. The type of sheet and armor of cable depend on the several factors. Depend on the design of the cable, and depends on the method of installation, and depend also the kind of infrastructure the cable will be put it in. When use direct boring and induct installation, we can use totally dielectric cables or armored cable, normally with corrugated steel tapes. Both could be used. In aerial installation, the all dielectric cable are recommended. In OPGW, cables are one alternative also for this aerial cable. And in this case, it's necessary to take care about some situation that could cause problems related to the signaling system or the traction line of the railway. But some people use successfully this kind of cable. Also, one important point to have in mind is one of the various types of infrastructure to be used depend the kind of the environment we can find all in both in urban area and rural area. And one of the main recommendation about this aspect is to use the existing infrastructure the more it's possible. Because one advantage of this kind of installation is related to the available infrastructure. The more the project of the cable not consider this infrastructure, the more the project will put aside one of the main advantages of this application. And if one use the metallic armoring, it's very important to consider the ground periodically and to the way of the fiber. And there is some big set of recommendation and the series K that refers to this subject. In ITU, all the aspects related to the lightning protection or electrical protection are dealt with this series K of the ITU recommendation. Its same comment applies to the other OPGW cables. If duct installation is used, it's necessary to consider the choice of the company of totally dielectric or metallic armored cable. If this duct is free of other influence, it's sometimes it's useful to have more than one duct in an infrastructure, and sometimes one duct is used only for the cables for communication. And then in this case, it's better sometimes to use dielectric cable. If there are some situation that could get some risk to the cable, it's better to use the armored cable. Depending on this cable design, the way of install the cable, the method of installation, we use the traditional way to pull by the end or blowing method. In any case, it's always necessary to have the precaution to hand well the cable, to choose the splice box and to install correctly, and also to have the excess of length of cable in this part where the job needs to be done. In this kind of application, the personal security is very important because sometimes we have high-speed train, we have some places people need to work in the cable and they are very near, then it's necessary to do a good survey, to choose the right place to put this splice box, to avoid to put in danger the people that will later do some operation or some maintenance in this kind of cable. And in the case where the cable is laid into a concrete trench, is that most of the time is covered by plates, né? And then armored cable is recommended. Then. In case of directly buried cable installation, it's recommended that the cable is designed to protect the fiber from external shocks, attacks from rodents, and any other harsh environment conditions. And this kind of cable sometimes use armored with corrugated steel tape and other kind of protection. And some ambients near the railway are very dangerous for this kind of cable. And it's very important to know this route and to consider the environment that the railway is crossing, what could happen in this. And it's not so difficult to find situation where in the same way we need to use different kinds of cables to consider the local situation. Because when you are dealing with road, sometimes the infrastructure near the road is the same. When we are dealing with railway, could be different when this railway cross some urban, some non-urban area, could cross always some wide area in sometimes, and there are it needs to consider protection, including against termites and rodents and this kind of natural agent. In this kind of application, all the methods of installation should be used, and there is necessary to have a strong connection between the cable and the cable design and the method of installation. In this case, I mentioned before, of using different kinds of cable in different parts of the way we are planning to put the cable. The idea is to have a transition in some kind of splices. Then it's necessary also to design splice box. They are adequate to attend both kind of cable if we have a transition. In case of aerial installation, the recommendation is to use totally dielectric cable, and in case of armoring of the cable against hunters, squirrel and birds and so, sometimes it's necessary. It's again some comments about the specific situation of part of the way the cable is put. This is one of the path of installation that could be substantially different one region to the other, in the same way to one city to other. Yes, sir? The other one?
to know the difference between total dielectric cable and metallic armor cable, and what is the best choice between
The question is about the difference between two kinds of cables. When you have totally dielectric cable, uh, all the elements must be designed for this, and the cable will be light and you be strong enough to install and to resist the wind condition and so. And one of the big advantages after consider this physical situation, it's easier to install, it's easier to move the cable and so. One of the big advantages is that we don't need to worry about the electrical protection of this cable. Then one of the, it's a lot of application of this cable. In the beginning, all the cable used to have some aluminum tube inside the cable. It was a protection against water, especially in the beginning of the optical fiber cable. After some improvement of the fiber, he became more resistant to this water penetration, and this development includes changes in all the materials used and some changes in the process. Then the cable could be without any metallic and could be a good protected cable. And even though in some places people use to install in submarine cables in short distance, they used to install this kind of totally dielectric cable because the fiber is completely free. The fiber is always will break under tension. If the fiber is not under tension, it's completely free, the cracks in the surface will not increase and it's okay. Then there are a lot of advantages, including this installation in electrical towers in a good position, well protected, in a region that is protected for a lot of elements. Then these are the advantages. But when we need some kind of mechanical protection, because like just choose some things that are mentioned here. When we have rodents that's trying to find a way, and if the cable is the way, they just destroy the cable and go. We need some protection, and armored cable to be a good protection. When we have some box of cement, like mentioned before, that is cover. One thing that could happen is someone is open the cover and the cover just drop inside and reach the cable and the fiber will break. Then there are some occasions that's better to have a metallic protection. Then the armored cable is a good choice. Then I think it's why I mentioned before, if you need to put optical cable in a railway 100 kilometers, go and see what is in there. Some people use to receive just maps and go to the end and know the situation. And it's very important to have a survey to look in the field to know what are the conditions with the experience we are mentioned here. Because someone could look to other things more related to problems related to electrical cable and said, okay, it's a good infrastructure. But sometimes they are not seen, and sometimes it's easy. When you look at one of these boxes, you can notice that the cover was breaking the ends. There are some marks in the bottom in the box that sometimes something drop in there, and you say, okay, I need to protect. It could be done sometimes using an armored cable, and other times just putting a protection in there. Sometimes putting just a tube in that portion, protect the cable, and still use the dielectric cable. So that's the idea. Then always we are dealing here with lightness. The totally dielectric is a light cable. It's a very easy to install and to keep spare. And always we are looking here to find the ways to protect more the cable, especially mechanically. That's it. Any other question about this? And it's important to have a general view of all the process. I just stopped a few minutes talking about we are dealing here and talk about professional experience. Because we have a lot of people trying to do the right thing. We have people developing fiber, developing cables, developing machines to install and to repair. And most of the time, what we want in this kind of element is to have a good experience put together. If we have a more mature technology, sometimes the information is more understood and the developments are more in a good level. And the recommendation could be more superficial. If you have, people are aware of some things and they do the right thing. Another time when we have new technology reaching the market, people are more concerned about detailed and want to indicate in recommendation that one thing is important, other thing is important, other thing is important. That's why sometimes some information of the best way to use we find in some documents related to the people who manufacture, and other time we find in information in people of trying to put together the different players. That's it's really important to have it because as the minister says yesterday, the experience come with time, and we have a lot of good source to get a good level of experience. And recommendation means a good way to know about these topics, but sometimes we need to go more looking to the people that manufacture the machines and to do the project and supply the materials. Yes, Gary? Okay, we are 5 minutes from the very important lunch time. Then I will read some good point here and we can stop for the lunch. Thank you, Gary. Okay, the pole material for railways power supply can be concrete or iron, and additional poles should be made of wood, concrete, steel, fiber, or plastic, depending on the cost and environment impact stood. Sometimes we've trying to put optical cable in this ambient is easy to find some infrastructure, but sometimes it's necessary to put some extra poles just to attend the necessities of the cable installation. There are some particular points listed in this recommendation, and it's put in handbook. And then the first one is a cable installation through single points like tunnel or bridge requires some additional protection and special protection. Except gives fire retardant sheets. Then there's some points it's better to put a special cable with fire retardants. And in case the cable is installed in tunnels, it should be bound in appropriate way, fixing in a support and apply all the recommendations of the other text we discussed before. On the wall with staples or using ducts. It's almost the same information we have in normal bridges and tunnels. Always in bridge is recommended to use ducts. There are some points that are pointed in this recommendation. Uh, in referring to poles, when using the railway's power supply pole line in the installation of the optical cable, cable can be suspended from the field side or from the railway side. Then you have almost all the time we have the poles that is installed to run the trains, and the cable could be in one of two sides. There are advantages here, and advantage is better to look to each situation. The minimum vertical distance from ground level when cable is installed in field side or from the top of the RAN when cable is installed in railway side, the recommendation is to have more than 5 meters or equal to 10 meters. The idea is to put the cable so far from the ways that could affect this material. Horizontal separation from the leaf conductor will depend upon the design of the pole line, taking into account the safety requirement for works. It's a very specific situation. We need to take care and use very varied skills to find the best way. The span length distance between poles depends on the laying characteristics and the cable design. Of course, there's a lot of poles in between that was designed for the running of the railways, and the project of the optical fiber cable must find the right poles to give the span necessary considering the design of the cable. And it's a recommendation about nominal cable sag. It's good not exceed 3%. Oops. Cable should be suspended on all poles in an appropriate way, depending on the cable design and the laying characteristics. A common way to use is to using clamps and pulleys. In special positions, price points, end of the road, every given number of pulling, the cable should be fixed to the pole. It's necessary to fix the pole, or in the pole, always. Splice. When splices are installed in manholes, it's possibly suitable to make the splice inside or outside the manholes. In both situations should be considered, as well the characteristics of the splicing box, manhole, and the cable, and the personal security. Then the main point of this clause in the recommendation is that we need to use the experience of other applications, but we also need to consider the particularities of this installation. In any case, a length of cable should be stored in the manhole in order to allow the correct fulfillment of the splice. And then it's recommend 5 meters in each end of the cable for splice. When we decide to do this splice outside of the manhole, the recommendation is to use 10 meters in each side of the cable. Someone think could be more than necessary, but if you are dealing with 2 kilometers, to put 4 or 10 meters is better to be conservative than to discover later why it could be important to have this extra length. In an aerial installation, this splicing could place in the top of the pole or in the ground. Then the people that will do the splice could be in one of two positions. As in previous case, a length of cable should be stored in the pole for cable splicing purpose. Stored cable length will depend on the position of the splice box and the place where the splice is carried out. To realize the splice not in the ground but in the top of the pole, it's more difficult, and to realize in the groove is more controlled. Some company has some equipment for special and do in the top of the pole, and some other companies prefer to do in ground. It's necessary to have this in mind and to have the personal training and the equipment and all the things necessary to good splice. I think we have more topics. I prefer to stop here and reconvene in this point because it's better to discuss, more time to discuss. If not, we can finish it. It's not in just not to discuss because it's dinner time. Then I prefer to have more. Then we can come back in the same topic. Okay. Thank you. Gary, what time it's manufacturer is respected? And inside the manhole, this splice box should be fixed directly or on the wall or using a kind of appropriate support, and it depends on the box design. And in aerial installation, it's recommended fixing the splice box on the pole and avoiding fixing it in line with the cable. Another recommendation is to avoid the installation of splice box inside tunnels or bridges. And if it's not possible to avoid its installation inside a tunnel, the splice box should be fixed on a support or directly on the wall. And this last recommendation finish the text related to optical cable along railways. And I'd like to ask you if there is any point we need to discuss at this point of the presentation. If you don't have any point to discuss, we can move to the next. That's cable in sewer ducts. Some cables are in some places installed in sewer ducts, and it's one of the cases I've mentioned before that there is no big experience. Then there is a lot of information put on the recommendation. The idea of installing cable with optical fiber in sewer ducts arises because it presents a lot of advantage compared with traditional trench installation techniques, such as less time for cable laying. This laying is not limited by weather condition, and because of the protection of these sewer ducts, it's an increased protection against damage. It's not necessary to stop the traffic. There is no traffic disruption during the installation. And also, at this installation, there's no problem with noise pollution. That's not necessary to do excavation. There is no damage to road surface or underground installation. It's not necessary to use heavy equipment, and there's no inconvenience to business or to citizens. Then the cable is put in a place very safe, considering this kind of subject. In general, there are two kinds of sewers. The one that's possible, a man go inside, that is called here man accessible, and that kind that's not possible, a man go inside is no man accessible sewers. The definition where a man could access or not depends not only on the regulation that each nation or each country has, but also in individual regulation of different sewers network operation. Then depends on the country, depends on the administration, and also depends the sewer company. And usually, when we have uh, diameters between 200 millimeters micrometer and 700 millimeters, we consider a non-accessible to man. In this case, the installation of an optical cable in these no-man accessible sewers is carried out using a kind of mechanical apparatus, or usually called robots. In the case of man accessible sewers, we can use robots, or we can use the installation of cable using man's or a manual installation. There are some different methods to install cables into sewers. The first one is traditional. You use traditional optical cable or micro cable. Eh, they, they are specially designed to put in protective ducts, and the ducts usually are installed before the installation of the cable. And the second one is a kind of self-supporting optical cable, uh, specially designed to be suspended in the top part of the sewers. And the third kind of is the is a kind of armored optical cable that are designed to be installed directly in the bottom of the sewers. And we have three different kind of network we can build inside the sewers. The sewer optical cables and our related infrastructure uh, must be designed and manufactured considering an expected life at least 15 years. And it should be possible to install and remove the cable uh, during this operation life. That are recommendation for the project of the cable and the system. The materials that are used in this sewer optical cable and also in the related infrastructure shall be not present a health hazard within its intended use. And there is a recommendation on this topic, and this recommendation is the L77. First, it's necessary to get a lot of information about the structure condition. What is the sewer network in the region the company intends to put the optical cable? What part of this network has pipes that could be reached by a man, or it's necessary to be used in robot installation? What kind of different structural change occurs in the way of the we intend to put the optical cable. Sometimes there's some collapses, there's some pipe junctions, there are some device used to control the sewers that it's necessary to take it into account for the project of the optical cable to be put inside the sewers. It's important also know about the stack bearing capacity and hydraulics related to sewers, and this suitability for rehabilitation measure. And there's a lot of information about the capacity of static capacity, the hydraulics reduction of the section that could be caused by this infrastructure associated to the cable. Uh, if necessary, even if someone intends to put several cables in a pipe, it's necessary to know to calculate the effect of all this cable. Um, it's important to consider also the experience of the sewer network operator with respect to loading and what's the strategic plan of this company for the future. Because if there is some additional discharge to the sewer because of new interligation of new places or new flow, it's important to consider this, to do all this accounting, considering the new situation. Of course, the sewer network must be planned in the past, considering some dimensions that when we put an infrastructure, the, in some points and all the way, we will have some kind of restriction to the flow that's planned into the sewer. Other important thing is that the operation of the sewer network must not be affected by the sewer installation. Of course, it's not possible to interrupt the operation of the sewer networks, and the cable must occupy a good position in the ducts, uh, must adhere as much as possible to the pipe sealing. The technology used must assure that the cable installation will not damage the ducts, considering what will happen during installation and after that during operation of the cable network. In some point, it's important, especially when it's not all dielectric cable. It's important to have some grounding system to avoid some kind of induced voltage and sparkling, because there are some gases related to the sewer, and the cable could not be a cause of some explosion or something like that. In this way, at the entry or and exit of sewer pipes, it's necessary to put a connecting point for equipotential bonding between all the metallic parts of the infrastructure and the cable. And it's very important to register, report, to document, measure, and document these the aspects related to this grounding system. Um, the installation, when made by robots, uh, it's made in this kind of part that's non-man accessible, and it's important that the technique used should be damage-free, and it's include all kinds of pipe materials. It's useful to know all the way uh, of the pipe, because sometimes different expansions uh, could happen in the past, and could be parts with different kinds of uh, ducts. For example, using vitrified clay, using plastics, we're using concrete. Then when choosing a route for this cable, it's important to know what is the material of the pipes in each part of this sewer network and to establish the correct practice for the use of robot without causing any damage of these sewer ducts. Especially when we deal with anchoring, the anchoring installation method. It's not recommended because of the sewer pipe wall thickness could be weakened by doing drills and holes and might break due to the heavy load or pipe sagging. And the idea is to avoid to put some kind of special clamps that could put the cable in position and without mechanically damaging the pipes. In this way, one of the solutions is recommended is to put a protective conduit fixed by using a robot to the sewer ducts using special clamps equipped with clips, and after that the cable should be blown into these conduits and to assure that the conduits are in the right position and that this kind of clamps specially designed for fixed without doing holes could be good enough to sustain the conduits in the flow that we normally have in the sewer, and we always without damaging any of the pipes. Considering the materials that intend to be used to have a long lifetime, it's recommended that only stainless steel type materials are used in this kind of application. And most of the time, the cable must be protected against rodents and also again any kind of mechanical impact that the cable could suffer. Then the material based on stainless steel could be a good protection, could be a good choice. All parts should be designed to guarantee the minimum allowed cable band radius on the entire network installed in the sewers. This is the recommendation that we always need to have in mind. And again, it's necessary to consider all the way the cable will be and look at the bending radius. It's recommended also that the protective conduit could be the corrugated tubes, and that the maximum occupation, the maximum diameter of the cable needs to be 70–80% of the corrugated steel tube diameter. All this recommendation refers to the non-main accessible sewers.
I'm asking, yes, in this kind of installation, no man accessibility, so how to protect this fiber? In the protection of this fiber is once you use this fiber, again, if I use HDP pipes or GI pipes, is it possible in this pipes?
Is it possible to use plastic pipes, but it's not recommended. The recommendation is to use stainless steel corrugated pipes. But depending on the information specifically of some other sewers network could be used because, but the more conservative way of protecting the optical fiber cable is stainless steel corrugated uh, conduits. But if you know what kind of sewer specifically have in that region, you know enough to consider that the plastic high-density polyethylene, for example, in a good thickness of wall could be a good choice. It could be used. It's, the more conservative will be used the stainless steel and corrugated tubes. But depends on the cave, it's possible because the infrastructure related to this kind of network varies a lot from country to country, from place to place. The idea is always keep the cable in a good protection way. And of course, one thing it could be done is a kind of pilot. You be a test in some region and use. As plastic material resists to the abrasion, to the flow, to the materials that are involved, could be one possibility. Use tubes based on plastic materials.
Uh, adding some more remarks on, adding some remarks on his question, he was talking about HTP. It's the high density polystyrene pipe. So it's not expected to use it. You should put the corrected pipe tube, and then inside you put this HTP, and then you put the cable. So the cable is more protected. It's also to put only this HTP. So it's not excluding to use this steel pipe.
Thank you.
I don't have a question. I want to show you. Can you come beyond? Yeah, first. This is one, no? Okay. And second. Maybe this is the first and after.
Back.
Back is a face. This is a face for the back. This is a face, and after this you have 1.10.1. Can you continue? After this you have what? Yeah, next. Okay.
It's okay. Thank you. Well, something changed here. Okay, it's an considering the main accessible sewers. We need to put some clip holders and put the conduits fixed by this. We need to use the protection of stainless steel corrugated that could contain, of course, and other kind of protection inside. This kind of clip holders installed by men, they have some expansion bolts. In this case, we have normally the wall thickness sewers is around 800 millimeters, and it's possible to drill holes and accommodate the expansion bolt without causing any problems. The idea is when generally we have some a kind of big structure. The walls are thicker also, and it could put some holes that drilled in this uh, system without causing any problem to the pipes structure. The maximum number of the protective conduits that could be installed depends on the clip hold sizer. In, in general, each clip holder allows the operator to install up to 4 clips and conduits. Then we have first to put the hole, and after that to put this structure of clips where used to install the conduits. The main difference is that in the first system is not possible to drill holes into the pipes, and this in second one, it's possible. Some information about the installation of special armored optical cable in sewer ducts. The installation, as we have all the conduits put in right place, the installation of optical cable pulled in and laid on the pipe is the easiest solution to deploy the optical cable. Fastening the cable into sewer pipes is not necessary because the gravity keeps the cable on the floor, and the condition of the pipe is very important. In this case, we have that kind of armored steel protection, and the cable is just put in the bottom part of the sewer and stay in a very comfortable situation if all the condition of the pipe is relatively steady. To access the cable in every manhole, it is important to fix, and it's important to have a good survey in the installation process to have all the conditions to start the necessary maintenance. In this case, the cable is on the vertical of sewer pipe. It's recommended to plan a maintenance operation and eventually the pipe rehabilitation with liners, as in small pipe, the cable might cause wrinkle formation on inverted area. The idea is to keep the cable straight and sometimes in the future look what's in there. Sorry.
What about manhole in the sewer? Manhole, is it possible to put a manhole in the sewer?
This kind of network generally have some what we call inspection pockets. There's some position people goes down to inspect the sewers, and one of the recommendation is to have these splices or near this point of we can go there. It's not in the bed of the tube. The idea is to use the same necessity that the sewer operator has to go inside and to clean and to inspect, and to, in this case, put a cable in a more comfortable situation considering the access in the future. Okay, then it's better to keep just the cable in the sewer line and to put all the things in some place that could be even outside of the sewer in a box prepared for this. It's better to have this kind of things. Then just the cable use the sewer, and in some point on we have a way out, wing of the people to do maintenance and so of the sewer. We use also to get the cable in a position when it's better to work when we need to access. It's more use it, do this kind of way. Of course, if there are a lot of different conditions involved in sewers network, and the idea is always to try to put the advantage of using that sewers network and put all the points that we necessitate to have some kind of different access to the cable in a condition that's more easy to work when need to access. Okay. Referring to tightening method, the cable would under high tension from manhole to manhole at the sewer top. A high tension load of several tons created by means of tension fixture, and it's not recommended. It's always necessary to consider a kind of protection that we referred before, always thinking about the load that effectively reach the cable. Sometimes the protection tubes are under a certain kind of load, but as we cable are free inside, we can try to avoid any problem to the cable. About some guidelines for the selection of the most appropriate installation method. I didn't put here, but it's a table that compares all the installation methods. And in considering this specific situation, it's good to take into account what could be more effective. One important point to consider in this case that is normally a good procedure of maintenance. Wash with pressure water, and after that to do some finish brush, to apply a finish brush to clean the sewer. Then the sewer ducts must be cleaned every 2 years using a high pressure water washer, and a vacuum cleaner system normally is adopted. In this way, any cable or conduit that is placed into a sewer must be projected to withstand the rigors of this pressure washing, and as frequently as every 2 years. And also this finish brush attachment, sometimes you use it for detailed cleaning work, and the cable and infrastructure must be projected to withstand this finishing brush without damage. Safety practice that the people involved with this installation or maintenance of the cable in this structure, there's always some special safety practice that are established by the local authorities or even the state laws that refers to work in confined space, that refers to the hazard associated to underground utility, trench, traffic, and traffic safety, equipment safety, and safe training in personnel. Considering these guidelines, these safety practices should be necessary, then it's a very different condition for the people that works with telecom or install cable. Then it's necessary to know more about the detail and to follow the practice, always considering the safety involved. It's a lot of details involving the gas we have in this ambient, involving the time the people could stay in this, what they can or need, where to be protected, their health points associated. It's important to know and to use correctly. I don't know if there is some experience in this area nearby. I know it's in Europe, it's very used, because in one of the reasons to do this was that there are some crowd uh, cities that's not so easy to get near the customer using new way to the cable. Then people start using some kind of facility network. Then this describes sewers, but there are some work being done also in water supply to the houses and in gas supply to the house. As the cable, totally, all the electric cable, it's a well protected material. People think in special cases, they put just inside of this facility that's already existing. Then the main point is just to get a safe way to go into that facility and a safe way to live in direction of the house of every people. And they try always to find some infrastructure that interconnect important place in this city, and also that interconnect the house of every customer to some place. Then what generally reach the houses are water, sewers, gas, electric networks. Then there's always someone trying to find what can be done in this kind of network. In Brazil, that's not very useful to have this. Most of the time we have other ways to put optical cable. In Europe especially, it's most